Now, what about this function? So we know that the absolute value of x is a V shape that opens upward. Now for this one, it's going to shift 3 units to the right. And it's going to shift 1 unit up. So the new origin is at 3, 1. And it's going to open in the same direction. For any absolute value function, the domain is going to be the same. It's all real numbers. However, the range can vary. The lowest y value is 1, and the highest is infinity. So the range is going to be 1 to infinity, and it includes 1. So we need to use a bracket. So go ahead and try this example. What if we have 2 minus x minus 2? So the graph shifts 2 units to the right. If you set x minus 2 equal to 0, x is 2. It also shifts up 2 units. So the new origin is at 2, 2. But notice that we have a negative sign in front of the absolute value function. So instead of opening in the upward direction, it's going to open downward. So it's going to look like this. The domain will be the same. It's going to be from negative infinity to infinity. But for the range, we can see that the lowest y value is negative infinity, and the highest is 2. So it's going to be from negative infinity to 2. So that's it for absolute value functions. Now let's move on to exponential functions. Let's say if we have the function e to the x plus 2. If you recall, e to the x was a function that goes up like this. And it had a horizontal asymptote of y equals 0. Now, the graph has been shifted 2 units up. So the new horizontal asymptote is y is equal to 2. So we should plot that first. So the graph is going to start from the horizontal asymptote, and it's going to increase. The domain for any exponential function is all real numbers. X could be anything. However, the range has restrictions. The lowest y value is 2, the highest is infinity. So the range is going to be from 2 to infinity. And since it starts from an asymptote, it does not include 2.